In the first video, I told you about the idea of a hypothesis test, that there is some data that's collected, some feelings that are had about where the true parameter value is, and then a claim that's made based upon that. So you're seeing things come out in the sample and you say, this is what I feel it is for the population. And then you test it to see whether that data is strong enough to support the hypothesis that you're making. So the way that we're going to go about and do this is called the traditional method. And so I thought I would just talk to you about the different steps that are involved. Each one of these needs to be explained in a little bit further, but we'll do that in subsequent videos. 8.1 takes some of these areas and has you practice just that point. And so that's why you have some homework out of 8.1. So the first step in the traditional method is to write the claim in symbols. So if we made a claim, if our claim that the mean income of FLC professors is greater than $75,000, well, then writing that claim in symbols is pretty easy. So I would highly suggest you always write the word claim. I'll model that every time. We're making a claim about the mean income of every FLC professor, right? And so the claim then would be the mean of everybody is greater than the 75,000 number. And that's what we'd be testing. Because we're making a claim about the mean, that's going to be 8.3. So you'll see this process fully worked out in 8.3, but this is all that's meant by writing the claim in symbols, putting what you're reading in words into symbolic form. From that, we're going to be able to identify the null hypothesis and the alternate hypothesis pretty quickly. And we'll use the methods of our book, so I'll reinforce those in another video. We're going to calculate the test statistic. And the test statistic is going to tell us the strength of the data. And so you're going to have a formula for that. You're going to be your big number drop in from data that's given. And we're going to see, hey, how strong is that data? To know how strong it is, we're going to have to find a critical value. So the critical value, and sometimes it's more than one value, is a benchmark. Like, hey, if your data is this strong, then say what you want to say. And so it would give us that benchmark to shoot for. So the critical values are going to change based upon what they'll call the significance level, and it's directly tied into confidence level. So we're going to get those pretty easily by a chart lookup. You're going to compare those two values and make a conclusion about the null hypothesis. And then you're going to use that conclusion to make a conclusion about the claim itself. The last thing you should write is some words that say that the claim is supported, or we don't have enough information, right? The data is not strong enough to make a conclusion. That's going to be the process. You're going to go through these 6 steps, and you'll get really good at them because they're pretty repetitive. So you'll have to do this in every single 8.2 problem, every single 8.3 problem, so you get really, really good at applying this traditional method. So again, those 6 steps: write the claim in symbols, identify a null hypothesis and alternate hypothesis, do a calculation of what we call the test statistic, identify those cutoff values, those critical values, compare those two results from 3 and 4, the test statistic and the critical value, and you'll be able to make a nice conclusion about the null hypothesis and therefore a conclusion about the claim. So it should be awesome. So the one thing I want to highlight, and it's written down here at the very bottom, we will not be using the p-value method. So the book is probably going to say use the p-value method unless your instructor suggests otherwise. I'm requiring otherwise. The reason for that is the traditional method is what keeps what we've done already in the book holistically right at the forefront. We'll lose a lot if we go to the p-value method. They teach the p-value method because it's the method of a calculator that's making the decisions for us. We're not going to need the calculator to make the decisions. We're going to be able to make those using the traditional method. So what's going to happen in the one area, I removed all questions that referred to the p-value. But in 8.2 and 8.3, when you look at your answers in the back of the book, they're not going to know what your instructor told you. So they're going to give you both the p-value and the critical value. You pay attention to the critical value because that's what you needed for step number 4. We'll model all of that. The p-value number, just overlook. You don't need to know it at all. It's just a different way to do the same thing. It's almost like I'm teaching you how to solve systems of equations by elimination only, never ever showing you substitution. They're both the same. They do the exact same, they accomplish the exact same goal. And so we're going to stay focused on the traditional method to write the claims and symbols, identify the null hypothesis and alternate hypothesis, calculate the test statistic, identify the critical value, compare and make a conclusion about the null hypothesis, and then use that conclusion to make a statement about the claim. Sound awesome? I hope it does.